Heat treatment is a process of heating and cooling a metal to achieve a desired set of physical and mechanical properties. In a simple term, heat treatment is the process of heating the metal to a particular temperature, holding it at that temperature for some time, and then cooling it back in some medium such as air, water, brine, etc. The process of heat treatment is carried out to change the grain size, to modify the structure of the material, and to relieve the stresses. It also helped to improve machinability, magnetic and electrical properties, wear, heat and corrosion resistance. Stages of heat treatment process. The stages of heat treatment process are levels in which the metal must undergo in order to achieve the desired properties. There are 3 stages of heat treatment process. They are heating, soaking and cooling. Heating stage. This is the first stage in heat treatment. It is done to change the structure of the alloys when heated to a specific temperature. Soaking stage. This is the stage the metal is held at a specific temperature for an allotted period of time. The purpose of the soaking stage is to keep the metal at the appropriate temperature until the desired internal structure takes shape. Cooling stage. This is the third stage, where the metal is cooled back to room temperature using any cooling medium. The rate of cooling depends on the metal itself and the medium for cooling. Types of heat treatment process. The following are the different types of heat treatment process. They are annealing, normalizing, hardening, tempering, surface hardening. Surface hardening include nitriding, cyaniding, carburizing, flame hardening, etc. Annealing. Annealing is the heating of a metal or alloy to a predetermined temperature, holding for a certain time, and then cooling to room temperature, to improve ductility and reduce brittleness. It is one of the most important processes of heat treatment. In the annealing of steel, the steel is heated above its critical temperature. It is held at this temperature for a definite period of time, depending on the type of furnace and nature of work. The steel is then allowed to cool inside the furnace. Purpose of annealing: to improve machinability, to produce a refined grain, to induce softness, to improve electrical and magnetic properties. Normalizing. Normalizing is defined as a heat treatment process where a material is heated to a pre-decided elevated temperature above its upper critical temperature. Hold at that temperature for a certain period of time, 10 to 20 minutes, and then allowed to cool freely in the air to reach room temperature. The normalizing process is usually applied to metals that have been subjected to thermal or mechanical hardening process to remove the internal stresses developed during the process. Purpose of normalizing: to improve ductility, to secure grain refinement, to relieve internal stresses, to reduce hardness, promote uniformity of structure. Hardening. Hardening is the opposite process of annealing. Hardening involves heating the metal to a sufficiently high temperature to dissolve solute-rich precipitates. Hold at that temperature for a definite period of time. The metal is then rapidly cooled to avoid reprecipitation. This is often done by quenching in water or oil. The quenching medium is selected according to the degree of hardness desired. Water is widely used quenching medium, but it results in the formation of bubbles on the surface of the metal. Hence, brine solution is used to prevent this. Purpose of hardening: to increase the hardness of metal, to increase resistance to wear. Tempering. When the hardening process hardens a steel specimen, it becomes brittle and has high residual stress. Tempering allows carbon trapped in a martensittige microstructure to disperse and enable the internal stresses to be released from the steel that may have been created from hardening operations. The steel, after being quenched in the hardening process, is reheated to a temperature below the lower critical temperature. The reheating is done in a bath of oil or molten lead or molten salt. The metal is held in the bath for a period of time till it attains temperature evenly. The metal is removed from the bath and allowed to cool slowly in still air. Purpose of tempering: to reduce brittleness, improve ductility, strengthen toughness, relieve internal stress, increase wear resistance. Surface hardening. Surface hardening treatment of steel by heat means to increase the outer surface while the core remains relatively soft. The combination of a hard surface and a soft interior is greatly valued in modern engineering because it can withstand very high stress and fatigue. Various forms of surface hardening include carburizing, nitriding, cyaniding, flame hardening. Nitriding. Nitriding heat treatment is one of the several surface hardening heat treatment processes. Nitriding diffuses nitrogen into the surface of certain metals, creating a hard surface more resistant to wear and corrosion. In this process, the steel or metal is heated in the presence of ammonia environment. During the process of heating, nitrogen gas is released from ammonia in the form of atomic nitrogen, which reacts with the surface of the parts and form iron nitrate. The metal is taken out, and it does not require any quenching or further heat treatment. Purpose of nitriding. The main purpose of nitriding treatment include to increase wear resistance and improve fatigue life, to improve the corrosion resistance of the material, to harden the surface of the steel to a certain depth. Cyaniding. This is the process in which steel is heated in the presence of sodium cyanide or potassium cyanide. It is a process of superficial case hardening, which combines the absorption of carbon and nitrogen to obtain surface hardness. The parts to be treated is dipped in a molten cyanide salts, both maintained at a temperature of 800 to 850 degrees Celsius for about 15 to 20 minutes. The decomposition of sodium or potassium cyanide yields nitrogen and carbon from carbon monoxide, which is diffused into the surface, resulting in hardening the surface. The component is then taken out and then quenched in water or oil. Purpose of cyaniding: to give a clean and bright appearance to the hardened surface, to increase surface hardness, to increase wear resistance. Carburizing. Carburizing is a heat treatment process in which iron or steel absorb carbon while the metal is heated in the presence of a carbon-bearing material, such as charcoal or carbon monoxide, to make the metal harder. Purpose of carburizing: to increase the hardness of the outer surface of a metal, to increase the carbon content of low-carbon steel, to produce a wear-resistant layer. Flame hardening. Flame hardening is a heat treatment process where oxyfuel gas flames are directly impinged onto the gear tooth surface area to be hardened, which is then subjected to quenching. Purpose of flame hardening: to improve machinability, to increase wear resistance, to improve hardness.